Good morning. My name is Kiera Zimmerman, and I'm going to be explaining today to you how I got through Module 1's lab. So here's my ID, if it's needed. Okay. So Module 1's lab was about taking 7 unknown compounds and trying to identify them using multiple different tests. So we used pH paper to determine whether it was acidic or basic. We used potassium permanganate, which indicates, bear with me as I look at my notes, the presence of alcohols and aldehydes, no ketones, but it's an oxidizer. We also used, I put my iodine away already because I didn't want it to get everywhere, but iodine, and that will indicate the presence of methyl groups. And then I also used, it wasn't really a big part of the lab, but the Benedict's reagent to see, because it mentioned that only one of the compounds would actually react with it, and I thought it might be a good clue, so we thought we'd give it a whirl. Okay, so using all those different tests, I ended up making the different vials here. As you can see, some of them solubilized, some of them didn't solubilize so well, and then this is over here on the paper plate, my results. So we'll just kind of stay on the results for a while. I know that they're a little bit different colored, they're a little bit dried out, because I've been working on my lab, and now that I'm making the video, it's kind of dried out a little bit. But the photos that I took when I first did the lab are still kind of when it's fresh, so I could refer back to those, and you can take a look at them as well. I know the pH paper's kind of faded out since. Okay, so the lab gave the first indication, gave a pretty big clue. Let me pull it up. It talked about that one of the compounds in this lab is an antioxidant. That compound would colorize both iodine and potassium permanganate. We only had one that had a very specific reaction, which would be E here. Okay. I noticed also from the pH paper that it's an acid. So, and there's 3 acids listed. Because it's got a pH low. Looking at the results on the pH paper, it's a low pH, so it's acidic. So after doing a little work to see which one is antioxidant, we went with ascorbic acid. So with that, there are 2 other pH, two other low pH unknowns, F and G. You can come back and look here. So it's kind of hard to see, but I know that these were acidic. And then you can also see here, it's kind of dried out, but G oxidated with the potassium permanganate pretty seriously. F kind of did, dried out, so it's hard to tell now, but I know that when it was fresh, there was a little bit of reaction, but not much. So with the potassium permanganate, I know that indicates the presence of alcohols or aldehydes. When you look at the difference between the structure between benzoic acid and salicylic acid, which were the 2 options, salicylic acid has more alcohols, so I would expect a stronger reaction. So G became our salicylic acid, and F became our benzoic acid. Okay, so now we have the 3 acids taken care of, and now we move on to the more basic compounds. So let me look at my notes. Okay, out of all the basic compounds, only one oxidated, which was C here. And it's tough to tell, but we kind of spread out the dot a little bit, and this one turned kind of brown, so I know that it oxidated rather well. For that one, I chose xylitol, because xylitol's got a bunch of alcohols, which should have oxidated with the potassium permanganate rather well. Also, C here also solubilized rather well. So I know that it wasn't caffeine or it wasn't thymol, because caffeine is only mildly soluble and thymol is not soluble in water at all. So I ended up choosing xylitol. Sodium acetate shouldn't have created a reaction with the potassium permanganate. Going back to my notes, the only other unknown left at that point that had solvated was D. It's pretty clear. So I went with salicylic excuse me, sodium acetate as D, since it's the only one that was left that was soluble in water. So that leaves caffeine and thymol, which was A and B. So I had a really hard time with this one because I had those two compounds when I did my tests came out with the same results. So both of them are hydrophobic. You can see here there's some crystals, and this one, like, you know, it's that white milky stuff that didn't mix with it very well. Both of them have a low pH. Both of them produce precipitate with the iodine test, and both of them, or neither of them, oxidated with the permanganate test. So I had kind of a hard time figuring out which one is which. In the end, I figured out that caffeine is mildly soluble and thymol is not soluble at all. So because B has this great like white, like I had a really hard time getting it to mix in. And although A does have some crystals in there, the crystals did shrink in size and some of it did actually solubilize. So I chose caffeine for A and thymol for B. Something I forgot to talk about down here on the reagents, I noticed that only one of them reacted, which was E. And E, I had guessed, was ascorbic acid. When I went back to look at the structure, it also was the only one that had an alcohol on a carbon bonded to a carbonyl. So that kind of, to me, you know, at least locked in ascorbic acid, probably the only one I'm really sure about. I think that the tip that I learned in watching the lab video was very helpful about kind of spreading out your dot a little bit. Like I had a hard time reading the potassium permanganate dots because they're so dark, you know, and so I kind of had to like kind of drag a nail through it and get them to spread out just a little bit. And once I did that, it was a lot easier to read. I could tell that, you know, this was a little more brown, this one was a little more purple after spreading it out, so that was a pretty useful tip. Otherwise, I guess for my final results, A turned out to be caffeine, B was thymol, C was xylitol, D was sodium acetate, E was ascorbic acid, F was benzoic acid, and G was salicylic acid. So yeah, in conclusion, I guess just, you know, narrowing it down using these tests, it can be a little bit difficult because it can be subjective. Like, did it really dissolve? Did it not dissolve? Did it kind of dissolve? Is it purple? Is it brown? But for the most part, by using multiple tests, it's a little bit easier to narrow it down and be more specific. And then making those predictions based on the structure also helped out quite a bit as well. So that's my results from Module 1 Lab, and